In this video, we're going to look at another special case of factoring. Factoring expressions that require the sum or difference of cubes formulas. If we look at our first example on the left, 27x cubed plus 125, we'll notice that we have two perfect cube terms separated by a plus sign. In order to factor this, we can use the special formula for the sum of cubes. That formula is a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. In order to factor this expression, we just need to find the values and plug them into the formula. So let's do that. A squared, and a cubed. If I let a cubed represent 27x cubed, I know that the cube root of this term is 3x, so I'll plug it in for a. A squared would be 9x squared. And if I take a look at my b terms, b cubed is 125. The cube root of 125 is 5, so I plug that in for b. And b squared is 5 times 5, which equals 25. Now I have the values I need to plug into the formula. So, a cubed plus b cubed represents our original problem, 27x cubed plus 125 equals, and now we write this expression in factored form. In place of a plus b, we'll write 3x plus 5 times, and in place of a squared, we substitute 9x squared minus ab, that's going to be minus, and we have 3x for a, 5 for b. I'll multiply those together and write 15x plus b squared. B squared is 25. So using the sum of cubes formula, we have factored the expression 27x cubed plus 125 into this statement. Now let's take a look at one using the difference of cubes. Here we have 6y cubed minus 6. At first glance, we don't see perfect cubes, because 6 is not a perfect cube. But if we factor 6 from this expression, we get 6 times y cubed minus 1. Now, I do have the difference of two perfect cubes. So I'll apply the formula for difference of two perfect cubes. That's a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. And I'll set up a little table just like I did with the last example. We have a squared. Let me just erase that here. A squared and a cubed. Well, a cubed is where we'll put y cubed. A squared becomes y squared, and a is y. Now for our b terms, b squared, and b cubed. B cubed is 1, the cube root of 1 is 1, and 1 squared is 1. So all of the values for b are 1. Lastly, we just need to plug this into our formula. Y cubed minus 1 equals y minus 1 times y squared plus, and here we have 1 times y, I'll just write y, plus b squared, which is 1. Now in the beginning we factored out a 6 from the original expression, so our final answer needs to include this. So our completely factored expression is 6 times y minus 1 times y squared plus y plus 1. So here you have an example of factoring the sum of perfect cubes and the difference of perfect cubes. Hopefully you have found this video to be helpful.